file folder, there is, say, another help laboratory, which is all about the motors. And you just, because you want to experiment every single part separately, right, to make sure it works, but then you can combine things. So once you have this done, the only thing you would like to do for just without collision avoidance is to just make sure that the thing starts driving according to your joystick directions. It's the same type of motor, but it's not. But it's not the same. It's not the same robot. So it's a different robot. But yes, it's the same stuff. That's why I trust everybody to just look at those files yourself. So in that file you also see some slides about the sensors, so how to work with those, and there's one slide on what is that called again? PID control. So the idea is then that you again want to, if you want to have smooth transitions, and we are humans, we may go too fast with our hands. You want to have some knowledge about the past, and you take that together with the current impulse that you received, and maybe some other predictive understanding with respect to an error or whatever you have measured or whatever that is, what you do, and then you can translate it like that into a movement of the car.
Are we going to be fully controlling the car?
Yeah.
And how does the collision avoidance work?
Ah.
It seems the object would stop unless you know on the OLED, or
That is one option. So you could decide to. So it's really up to you what to do. You could stop. You could make the car turn around, for example, just because you like to do that. You could decide if you see an object that you always try to steer away away from it. So you have maybe preference to go to the right. I mean, in normal life you would not do that, but it's your project. So now you have flexibility to work on, just to see what you can do. So I would like all the students to think a little bit through about, not just do the pure basics of the final project, but maybe do a little bit of interpretation on what you would do. For example, you can, which would be much harder, you can try to think about how can I avoid collisions with moving other robots. I will not let you guys run into one another, because then you will actually damage your robots. But how would you do that even? I mean, that's not so straightforward either, right? Actually, so that's actually not at all straightforward. So only if you have a lot of time, you can think that through. But once that is all set up, then you will actually you can have your final project pretty fast all together at the very end. So then you would have the SRAM, right, that has the character map for your OLED. The OLED you in this laboratory already use to display values. You get the joystick to work, you get the Bluetooth communication to work. The only thing that you now need to add is the motor and the sensor. And then you finally are at the base, because now you have all these libraries effectively. You pull them all together, and then you can write the main code about collision avoidance and how do you do that. And that's it. Now, maybe you would then at the end of the semester decide to actually use a real-time operating system to investigate whether you could work with that, but maybe not. Maybe that feels too overwhelming. Could be, but who knows? Maybe you feel. It depends on enthusiasm, motivation, and time, right? And maybe at the end of the semester it's too stressful though. But still, we will be talking about real-time operating systems. So that's it. Yeah. Cool. All right, let's go to the laboratory, and then.